Good evening, viewers of NTV and my dear students who are watching this program. My Teacher, which is UAE's biggest classroom. Today, I thought of discussing a few things related to 10th standard physics and even some areas we will spend some time for 11th grade as well. So, what my plan today is, those are doing, because for 12th standard last week we had a session for 12th grade. Today we will take up some from other classes, but next week again we will come back to 12th grade again. But at the same time, I would request you to watch this program and find out if you have any confusions to clear. You can very well call us and find out what exactly the solution is. My today's plan, first before the break we will we will do some questions related to 10th grade physics. After the break we will think of some questions from 11th grade. So, my dear students, you may plan accordingly. In case if you want more questions to be solved from either 10th grade or 11th grade, you can very well tell us. So, today, in other words, we can say according to your requirement we would be able to proceed with whether to do with 10th standard questions or 11th standard questions. But from my side, first half we will discuss questions from 10th grade, right, 10th grade physics. 10th grade physics basically the essay 1 portions, we have 3 chapters to be completed. Electricity is the first chapter, magnetic effects of currents is the second chapter, and the third one is sources of energy, right. So, of which electricity, some points, basically there are 2 areas we have in electricity. First one is Ohm's law, right. Ohm's law equation you must be familiar with, V is equal to IR, that is Ohm's law. Then we have another equation that relates what are the factors that that is coming. So, you can see on the board what is Ohm's law. Ohm's law, you can see it is V is equal to IR, right, V is equal to IR. You can make out one thing. See, if you increase the voltage, see what happens to if you increase the voltage, let us see. Okay, if you increase the voltage, see, resistance is constant, but current is also increasing. Decreasing voltage will decrease the current, right. Decreasing voltage decreases current, increasing voltage increases current. What is kept constant is resistance. You see, but the next one, if you change resistance, see what happens. As resistance increases, current decreases. You can see from the equation, V stands for voltage, sorry, V stands for voltage, I is current, and R is the resistance, okay, resistance of the wire. R is resistance, see this is resistance, and this one is current, and we have V voltage, right, these 3. So, from that what else you can make out is decreasing voltage decreases current, R is constant, right. See, this is what is Ohm's law. V is directly proportional to I. The more the potential difference you supply, the more is the current produced. You could make out that, okay. And even resistance also, when you increase the resistance, the current decreases, right. I will show you another concept related to this. Now, you can watch the monitor. See, the resistance is equal to rho L by A. See, in this you can again make out rho is the resistivity, or what is also called specific resistance of the material of the wire. It depends on what all factors, the nature of the material and temperature. L is the length of the wire and A is the area of cross section. See, if you increase the resistivity, that is resistivity or specific resistance of the material, resistance also will increase, right. That is one change. If you increase the length, you see resistance also increases. If you increase the area, the resistance decreases. That is, resistance is inversely proportional to area, whereas the resistance is directly proportional to length. Length increases, resistance also increases. But resistivity depends only on the material. When resistivity changes, resistance also increases, but you can see L and A constant for a given length and given area of the of different wires. Different resistances we will have. Okay, resistivity increases, resistance also increases. As length increases, resistance increases. So, what will you make out? A question you may be asked this way: what are the factors that influence the resistance of a given wire? From that equation which I wrote, which I showed now, you can make out one thing: the resistance of a wire depends on resistivity first of all. Resistivity, but depends on what all factors, temperature and nature. Then length, area of cross section. So, there are 4 factors on which resistance of the wire depends. Resistance of a wire depends on 4 factors. One is nature. Nature means which material it is. Then temperature. As temperature increases, resistivity also will increase, because the electrons are moving through the conductor. When temperature increases, the collisions will become more vigorous, there will be more obstruction, more resistance. Okay, temperature increases, resistance also increases, and when area of cross section increases, resistance decreases. Then length increases, resistance also increases. So, once again, resistance depends on 4 factors: the nature of the material, temperature, the length, and area of cross section of the wire. Is that point clear? So, now I will explain a few questions based on this lesson. Okay, so, the first question, one second, I will show you the questions one by one. Okay. Now, look at the question. So, question asked is, which consumes more energy, a 250 watts TV set in 1 hour or 1200 watts toaster in 10 minutes? That is 250 watts TV set or in 1 hour, okay, or the other one is 1200 watts toaster in 10 minutes. Which one consumes more energy? How do you find out? The equation we have for energy, okay, energy is equal to what? Power multiplied by time. What's the unit of electricity, like the commercial unit of electricity? For the consumption of electrical energy, how do we measure the electrical energy, amount of electrical energy consumed in house? When you get electricity bill, you can see the consumption in bracket you might have seen, units, okay, units, how many units of electricity you are consuming, that is what is measured, and on the basis of that only we are paying electricity bill, right. So, unit of electricity, when you say unit in general, what does it exactly mean? Unit means nothing but kilowatt hour, that is unit, right. And what is that is a unit? Unit means kilowatt hour, that is 1 unit means 1 kilowatt hour. So, what do you mean by how much you can say, or when can you say that 1 unit of electricity is consumed? 1 unit of electricity is consumed when 1 kilowatt of device, a device of power 1 kilowatt is continuously used for 1 hour. 1 hour, 1 kilowatt electrical appliance consumes 1 unit of electricity or 1 kilowatt hour of electricity. So, to get the amount of energy, to measure commercially, we want to get it in the kilowatt hour unit. To get the power should be in kilowatt and time should be in hours. So, in the first case, how many kilowatts of energy? First case, let us write like this: kilowatt means you divide it with 1000, this many kilowatts, this is 1 hour. So, time is 1 hour only. So, how many kilowatt hours? This is nothing but 0.250 kilowatt hour. This is the electrical energy consumed in 1 hour in the first case. And about the toaster, what is the amount of energy? The kilowatt, in kilowatt, how will you write this divided by 1000, that is 1.2 kilowatts. And 10 minutes, how do you put it in hours? 10 minutes means 10 divided by 60 hours, that is 1 by 6 hours, right. So, this is 1 by 6 hours. It's clear, this is in hours, 1 by 6 hours. Okay, you have to multiply it with time. Time is in 1 by 6. 1 by 6, if you divide it with 6, you get, see, 0.2 kilowatt hour. So, one is 0.250 kilowatt hour, the other one is 0.2 kilowatt hour, right. So, which one consumes more energy? TV in 1 hour consumes more energy. I think it is clear. It's 10 divided by 60, that is we are getting it in hour, right. So, it is correct. Now, you move on to the next question. Look at the next question. Okay. Next question. A piece of wire of resistance 20 ohms is drawn out so that its length is increased to twice its original length. Twice its original length, calculate the resistance of the wire in the new situation. So, what is the answer to that? A piece of wire of resistance 20 ohms is drawn out so that its length is increased to twice its original length. Calculate the resistance of the wire in the new situation. So, you look at the board. Okay. So, piece of wire resistance is 20 ohms drawn out so that its length is increased to twice its original length. We have seen just now the equation that is representing the resistance. Resistance directly proportional to length and inversely proportional to area of cross section. Okay, piece of wire of resistance 20 ohms is drawn out so that its length is increased to twice its original length. So, length is increased to twice. So, when the length becomes twice, what happens to resistance? Normally it becomes twice, correct, because they are directly proportional. But simultaneously what else is happening? When the length is increased by stretching, drawn out, okay, it is stretched to so that length increases. So, what should happen? When length increases, the area of cross section should decrease. That is when the length is doubled, the area of cross section becomes halved. So, this becomes halved, this becomes twice, right. So, that is in the numerator there comes a 2, denominator there comes a half. Okay. So, when 2 goes up, so the resistance becomes how many times? 4 times it will become. Okay. Resistance becomes 4 times. Is it clear? So, once again, a piece of wire of resistance 20 ohms is drawn out so that its length is increased to twice its original length. Twice its original length, calculate the resistance of the wire in the new situation. Okay, that is the case. Clear? So, that means how many times the resistance becomes 4 times, that is 4 times 20, that is 80 ohms. 80 ohms is the answer. Is that clear? So, once again remember, length, the change of length when comes, it can be in 2 ways. One is simply you are increasing the length by adding wires, or we are stretching it. But while stretching, not only the change in length to be taken into account, but you have to consider the decrease of area of cross section as well. So, when length is doubled, area of cross section becomes halved. So, both the ways, if you take both the factors into account, we see that resistance becomes 4 times. So, original resistance is 20, therefore, new resistance becomes 80. It's clear? Now, you may look at the next question. You look at the next question. Say in the circuit shown, determine the resistance across CE, that is one question. Okay. Then there is, I think you have noted down the question. There are resistors 2 ohm, 4 ohm, then there is a battery and a key like this. Okay, so the question, you have to find out the resistance across CE, that is from here to here, what is the value of resistance, that is the first thing you have to find. So, the first answer is, this is simply when you consider these two resistors just between these 2 points, when you consider the resistance between these two C and E, it simply means what? The whole resistance only, that is C and E means it is nothing but if you consider these 2 points, this also all the points, because there are no resistors here. So, both the points are connected together. That means these two are in series, that is in fact connected in parallel to 6. All right, that is in fact this alone, if you take into account how much is the resistance is 6, 4 and 2 together is 6. You know, you have done grouping of resistors. The other day Deepthi ma'am taught you about grouping of resistors, right. So, you can make out one thing from this, the total resistance in series combination would be the sum of the 2. So, 4 plus 2 is the resistance over here, CE alone, right, but that is in series with AB. Across CE and across AB, when you say, it is nothing but this whole resistance to be taken into account, which is how much? 6 and 6 to be considered in parallel. When 2 resistors are connected in parallel, what is the effective resistance? 1 by Rp is equal to 1 by 6 plus 1 by 6. Okay, so that is 1 by 3. It's clear. Therefore, total resistance across the combination is 3 ohms. So, 3 ohms is the resistance across CE or across AB or whole thing. Altogether is 3 ohms. And what about the total current? But by the way, one data which is missing in this is to calculate the current, let us say this may be given as 9 volt, the value of voltage should be given, okay, that is not given. So, now you can make out total current, we can find. How do you calculate total current? Total current is total voltage divided by, that is 9 divided by total resistance is 3. So, the total current in the circuit is 3 amps. 3 amperes is the total current in the whole circuit. Is it clear? How about the second part, the third part? Third part is current in AB and CE. Current in AB means this current. How do you find the current in AB? AB means across 6 ohms. How much is the? So, just have a look at the diagram. Across 6 ohms, how much is the current? So, but one thing is there, 9 volt is what is connected across the 6 ohm resistance. So, what happens is the current through that resistance, that is current in AB, is that voltage 9 divided by 6. Is clear? So, 3 by 2 ampere or 1 point ampere is the current through 6 ohms. So, that is through this current is 3 by 2 ampere. How about through CE? Through CE, that is through this, the current would be, how much is the resistance over here? 6. So, that also 6. Okay. So, that there CE also is 3 by 2 ampere, 9 by 6. So, 3 by 2 ampere current through this and 3 by 2 ampere current is through this as well. Now, what else you got to find is the PD across 2 ohm and 4 ohm resistance, that is how much is the PD across this and how much is the PD across this, and PD across this current into resistance, current is how much? 3 by 2, right, and resistance is 2. So, what will be the PD across this? This PD is 3 volts, right, 2 to cancel, this is 3 volts. So, what about the PD across this? Total is 9, no, this is 3. So, this should be 6, that way we can make out. So, 3 volt and 6 volts are the potential differences across these two, and the total current is 3 amperes. Current will be divided into how, this is 6 ohm resistance. So, two equal resistance means current will be equally divided, that way also we can say. So, total 3 ampere current would be divided into 2 parts, 3 by 2, 3 by 2, there is 1.5 ampere each. I hope you the question you got the answer clearly. This is the question and these are the answers to the question. I hope it is clear, right. Now, I will show you another question. See, look at the question. The first question lists the factors. This is actually a question from the board paper. List the factors on which the resistance of a conductor depends. So, how do you make out that? List the factors on which the resistance of a conductor depends. It means just at the beginning of the session I mentioned about it. Factors affecting resistance means which all? Nature, temperature, length, area of cross section. These are the factors. Okay. Now, look at the second part of the question. A 4 kilowatt heater is connected to a 220 volt source power. Calculate number 1, electric current passing through the heater, resistance of the heater, electrical energy consumed in 2 hours. Okay, so, these many details you will have to find. So, have a look at the question once again. A 4 kilowatts heater is connected to a 220 volt source of power. Calculate the electric current passing through the heater, the resistance of the heater and the electrical energy consumed in 2 hours. Okay, now look at the board. How do you calculate this? We have to find out current, we have power and we have voltage. Which equation you studied for power? Power is equal to VI, one equation we have seen. Therefore, what will be I? I is equal to P divided by V. P is 4 kilowatts. Kilo means what? 1000, right. So, 4 kilowatts means 4000 watts divided by V. V is 220 volts, right. So, this on solving you will get the value of current. Is it clear? Now, how do you find resistance? For which we have another equation to use. We have the equation P is equal to V squared by R. From that, what you can make out is R is equal to V squared by P. So, we have P as 4000, V squared 220 squared, solve and find that many ohms is the resistance of the heater. Another thing is electrical energy consumed in 2 hours. How do you find? Usually the commercial unit of electrical energy is kilowatt hour. We can calculate even in joules also. Generally the equation is what? Power into time. Power is 4000 and time is 2 hours. But you know, if it is to be converted into joules, the time should be in seconds, which is the standard unit. That is 2 times 1 hour is 3600 seconds. So, this many joules. So, once again you see the question, 4 kilowatt heater, okay, connected to 220 volt, and now you can see it on the screen, 220 volt source of power, and these many things, current, resistance and electrical energy, these three things you got to calculate. That is what is calculated. Now, have a look at the board. Power, we calculate power, we have this equation using which you are calculating current, then resistance we can use this equation calculate, and energy is power times time, power into time, that gives energy, right. Now, one more question. You do one thing, just look at the screen. Okay, I hope you read the screen, because I read the question from the screen, because I am going to go for a break. See, have a look at the question. After the break, we will discuss this question, but after the break, I will be focusing more on the 11th standard questions. Let us see if any other questions you have, those who are watching the program, 10th standard students, if you have any other questions or if you want me to solve more questions, you should call us and say, that time we will. So, this question, I showed you one question. If you know the answer, you can very well find out the answer and let us know. Okay. So, you can see the number on the screen and you can SMS as well if you have the answer with you. Okay. Anyway, I am going for a short break. After the break, we will come back and discuss more questions. Stay tuned and we will right back after the break.